Our third shape for the conic sections is the hyperbola. So the definition of a hyperbola is the set of all points x and y in a plane. The difference of whose distances from two distinct points, the foci, is a positive constant. So for example, in this case, if we do d2 minus d1, that's going to be some constant. Let's just say it's equal to, I don't know, z. I'm just choosing a random letter. The z is not super significant. Now, if we put a point over here and then draw from that point to these two foci, let's call that d3 and d4, then d3 minus d4 would also be some value z. So it's going to be the same difference either way. Now the graph of hyperbola is two disconnected branches. So in this case, we've got like a left and right branch. The line through the two foci intersects the two hyperbolas at the vertices. So we're using a lot of similar terminology that we've used in the past. The line segment that connects the vertices is called the transverse axis. Let's add that to our image here. So we got a transverse axis. And this is a vertex. This is a vertex. This is a focus. And this is also a focus. And then we also have our center in the middle there. So the midpoint of the transverse axis is called the center of the hyperbola. Now the standard equation of hyperbola is going to look very familiar, the big difference being that we have a minus sign here. So the standard form of a equation for hyperbola with center at hk is x minus h squared over a squared minus y minus k squared over b squared if it's horizontal. So the same setup that we had last time. And the other one, I kind of wish in the textbook referred to the vertical axis equation of a ellipse. Sorry, that's going to be a while to say in this order, but it doesn't. That's okay. So it's y minus k squared over a squared minus x minus h squared over b squared for a vertical. So again, let me go back to the original ellipse equations. They look really, really similar. The only difference is instead of a plus, we have a minus. So, oops, sorry, wrong page. Jumping back to it. So we're using very, very similar equations. Now the vertices are A units from the center and the foci are C units from the center. So we've got some similar things here. So A from the vertices to the center, and then for the foci, they are C units from the center. And the other part we have here, it says c squared is equal to a squared plus b squared, more similar to what we're used to with the Pythagorean theorem. So essentially all the signs that we had for in between our groups from ellipses to hyperbolas switch signs. The bottom part here, again, it's a very specific. At the origin, you have x squared over a squared minus y squared over b squared equals 1 if it's horizontal, and if it's at the origin and it's vertical, it's y squared over a squared minus x squared over b squared equals 1. Now, putting this into context, here's our two examples. We have a horizontal transverse axis, and that equation is x minus h squared over a squared minus y, oops, sorry, let's clean that up, y minus k squared over b squared equals 1. And in this image, we have two things we need to identify. The distance from this focus to the center is C, and from the center to the vertex, that's A. Now the other one, we got a vertical transverse axis, so we're going to do the y group first. We got y minus k squared over, a squared minus x minus h squared over b squared equals 1. And similarly, the distance from the center to the vertex, center to the focus is that C value, and then oh, wait, I kind of glossed over something here. I mislabeled this previous one. From the center to the vertex, I just went to the point that we had there. And the center to this vertex is going to be A. Whereas to find the standard form of the equation for the hyperbola with foci at -1, 2, and 5, 2, and vertices at 0, 2, and 4, 2, you'll see each of those has a y value of 2. That means we're going to have a horizontal line. So we have a horizontal transverse axis. And again, that's because the y values are constant. So it's going to be some sort of horizontal line. Now, let's start drawing this because we're going to need to find some key information for this. So we've got points at -1, 2. So we'll go 1 over 2 up. I'll draw a point there. And we also have points at 5, 2, 0, 2, and 4, 2. So I'm just going to go over 5 again. 1, 2, 3, 4, 5. And let's see. The other foci is at 5, 2. So this is a focus. This is a focus. And then our vertices are at 0, 2, right there. And at 4, 2, right there. Now, from this, let's go with our center. Our center is just going to be halfway between either the vertices or the foci. They end up being in the same spot. Let's just kind of zoom in on the vertices here. So halfway between the two vertices is going to be at this point 2, 2. So our center is at 2, 2. Now from there, we can get our A value and our C value. Our A value is the distance from the vertex, from a vertex to the center, and that's just 2. We don't know B, we'll calculate that in a minute. Our C value is the distance from the center to a focus, and that's going to be a whopping total of 3. Now again, to find, if we have A and C, we can use the C squared equals A squared plus B squared formula. Again, it's plus this time instead of minus like last time. Plug it in what we know. We have 3 squared equals, we know A squared, we got 2 squared plus whatever B is squared. That gives us 9 equals 4 plus B squared. If we subtract 4 from both sides, we end up with 5 equals B squared. Taking the square root of it, we end up with B equals the positive square root of 5. And again, since we're dealing with distances, we're just going to deal with the positive square root. Now, since this is a horizontal transverse axis, we're going to use the equation x minus h squared over a squared minus y minus k squared over b squared equals 1. Plug in what we know. H and k, I didn't label it, but remember, those are the x and y coordinates of your center. So we have x minus 2 squared over our a value was 2. That's also being squared. Minus y minus the k value, which also coincidentally is 2, squared over our b value, which is the square root of 5. That's being squared. All that equal to 1. And cleaning this up, on this left side here, we got x minus 2 squared over 4 minus y minus 2 squared over 5 equals 1. So that is our equation. Now, one thing we didn't draw on here yet, but the rest of this graph, the vertex opens, or that branch opens in the direction of the focus, so it's going to look maybe something like this. We're going to be coming up with more exact versions of this in a little bit. Let's try one more, like this. We're asked to find the standard form of the equation with the hyperbola with vertices 4, 1 and 4, 9 and foci at 4, 0 and 4, 10. So let's start by graphing this, but looking at this, you might notice that all the x's are constant. We're going to go over 4, and that means it's going to be on some sort of vertical line. So we got to go up. See, the highest y value we have is 10, so let's go up 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Hopefully you're a little more consistent in your spacing than I was. So we have vertices at 4, 1. So we got a point. Let me switch colors here. 4, 1, and another one at 4, 9. So that's going to be up here. And then we have foci at 4, 0 down here. That's a focus. That's a vertex. And another one at 4, 10. Again, that's a focus. That's a vertex. So in general, it's going to open up in that direction. We'll get more precise with this in a little bit. In fact, I'd be pretty rough with my sketches right now. So this is, again, a vertical transverse axis. Because our x values are the same. If you want to draw that transverse axis, you don't have to, but it's sometimes helpful to just kind of visualize how this is being cut in half. So it would just be a vertical line going up through there. The center, just like we had in the previous one, is halfway between the vertices or halfway between the foci. So I'm just going to go with the vertices because they're closer. So we had one at 4, 1 and 4, 9. Halfway is going to be at 4, 5. 4 away from each of those. Sorry, waiting for it to draw on air server. I think it's slowly showing up. I think it came there and come on. There we go. Okay, so we have that coordinate at 4, 5. Again, those are the h and k values that we'll use in a little bit. So let's label that H and K. The A value, again, is the distance from the center to a vertex. Our A value in this case is 4, going from the center to either vertex. We'll find the B value in a second. The C value is from the center to a focus, and that's going to be a total of 5. Same formula as last time. I'm just going to rewrite it in a squared plus b squared equals c squared form, just because that's more accustomed to me. A is 4, so squared is 16. We don't know what b is, so that's just b squared. 5 is our c value, so 5 squared is, 25. Cleaning this up already, or a little bit, some of you might already notice what the value for b will end up being. If we subtract 16 on both sides, we get b squared equals 9. We take the square root of both sides, and we end up with b equals 3. Now we've got enough information to plug this into our general equation. Again, we're using a vertical transverse axis, so we have y minus k squared over a squared minus x minus h squared over b squared equals 1. Plugging in what we know, I'm just going to kind of skip over a little bit here. We got y minus, our k value is 5. Remember, it's the y group here. Our a value is 4, so 4 squared is going to be 16. Minus x minus our k value, which was 4 squared, over our b value ended up with, I forgot to write that in here, that's 3. So 3 squared giving us 9, all that equal to 1. And that is the general equation for our hyperbola.